Great. Hello, everyone. Thanks for joining the second day of the Yocto Project Summit. We are really happy to have Leon Anavi here from Consulco Group, and he has an interesting talk about the Raspberry Pi 5 and what's so special. Leon, take it from here.
Thank you very much, Jan Simon, for the introduction. Thank you very much for everyone organizing this event. I hope you can hear me well. And in the next 25-30 minutes, I'm going to share my experience with Raspberry Pi 5. We're going to discuss what makes it so special. Is it special at all? So I work for a company called Consulco Group. I work remotely from my hometown, Plovdiv, Bulgaria. The previous background photo was from our Roman amphitheater. Consulco has a presence pretty much worldwide. We have engineers in North America and in Europe. I'm based in Europe. I contribute regularly to Meta Open Embedded and various other Yocto-related layers. My colleagues have also a lot of experience with the Yocto project and Open Embedded, as well as upstream contributions to U-Boot, the Linux kernel, automotive-grade Linux, and we do a lot of contributions to software over-the-air update technologies, which actually I'll mention at the end of the presentation. The agenda for today is around Raspberry Pi 5, of course. First, we're going to start with the Raspberry Pi OS. It's going to be a brief introduction to some of the key software features of the Raspberry Pi OS. However, the key player, the star of the show in the next 25 minutes is going to be meta-raspberrypi board support package layer, which is a community maintained layer. We're going to discuss it in a lot of details, and all examples will be around it. I have shortlisted some of the new features in Raspberry Pi 5 that are important, in my opinion, in terms of the Yocto project and Open Embedded. Of course, these are not all of the features that Raspberry Pi 5 brings. One very important feature in terms of hardware that we won't discuss in details is actually the Raspberry Pi RP1 chip that they've integrated on this new version of the board. This chip is responsible for the input-output communication. However, I don't find this as a significant change in terms of the software support that we do through meta-raspberry Pi. Therefore, due to time constraints, I'm not going to discuss it. I'll share some tips and tricks and kind of a historical overview about the different people and the different steps that were involved in the process of supporting Raspberry Pi 5. And of course, we're going to wrap it up with some conclusions. So let's start with Raspberry Pi OS. This is the Linux distribution that is provided by Raspberry Pi for their single board computers. It's based on Debian. It appeared with the very first version of Raspberry Pi in 2012. Back then it was called Raspbian, but shortly after that they've actually not shortly, but a few years later, they changed the name from Raspbian to Raspberry Pi OS. Initially, Raspbian was available as a precompiled binary for installation on 32-bit ARM Raspberry Pis, even though that they had already released on the market 64-bit capable ARM system on a chip inside the Raspberry Pi 4. They kept maintaining a single image that was 32-bit. This was because they wanted to have one image that runs on all Raspberry Pi models and versions. However, in 2022, 2 years ago, actually almost 3 years ago, they finally released the 64-bit Raspberry Pi OS image. I have to say that in the meantime, there was a 64-bit option to be built with the Yocto project and Open Embedded. We're going to discuss this a little bit later with meta-raspberry Pi. Something that's important, in my opinion, is how the graphical user interface changed in the Raspberry Pi OS. Initially, it was with X11, and in 2021, Raspberry Pi provided Mutter, which supported both X11 and Wayland, so it was possible to switch to Wayland and do some experiments. After that, in 2023, a year ago, they switched from Mutter to Wayfire because they switched to Wayland as a preferred default choice for Raspberry Pi 4 and Raspberry Pi 5. And this year, at the end of October, they switched again to a new Wayland compositor, WAP-WC, and now the Raspberry Pi OS runs with Wayland on all Raspberry Pi models and versions. So Wayland now is the default display protocol for Raspberry Pi OS. So what's so special about the Raspberry Pi OS that interferes any other approaches for building a Linux distribution with no matter what kind of build system you're using? Of course, here we're going to use the Yocto project and Open Embedded. They maintained a fork of the Linux kernel with some Raspberry Pi specific patches. There's also a repository with precompiled binaries for the bootloader and the GPU firmware. Raspberry Pi has a very specific boot sequence. They have a proprietary bootloader, and they have a file called config.txt. This is a text configuration file, which is similar to what we used to see in the BIOS of a regular PC. So with this config.txt file, we can turn on and off specific hardware configurations. The Raspberry Pi 5 firmware is self-contained in the bootloader EEPROM. And the Raspberry Pi 5 firmware defaults to loading kernel_2712 image. You're going to see this in the machine definition in meta-raspberry Pi in the next slides. So meta-raspberry Pi is the board support package layer, which you are supposed to use if you are going to build a custom Linux distribution for a Raspberry Pi using the Yocto project and Open Embedded. This layer has been started in 2012, the same year when the Raspberry Pi OS was started, and the same year when actually Raspberry Pi, the very first model, became available on the market. The maintainer of this layer is Andrei Gerzan. He has been doing this for many years. It's a lot of hard work, so kudos to Andrei and also to Cam Rush, who's also actively reviewing patches and GitHub pull requests in meta-raspberry Pi. The license is MIT. The contributions are nowadays are done through GitHub pull requests. And it's a very actively used layer because a lot of people use Raspberry Pi. It supports all versions and models of Raspberry Pi. So there are a lot of users, a lot of GitHub pull requests, and it's a great example of a community driven BSP layer. Keep in mind that Raspberry Pi as a company is looking after the Raspberry Pi OS, but they don't pay attention to meta-raspberry Pi. It's a community work out there. Due to the very specific configurations and both software and hardware of Raspberry Pi, there are some specific settings that are coming from meta-raspberry Pi. Meta-raspberry Pi has a very good documentation, and all these options are described there. However, this is just a very short list of some interesting Raspberry Pi specific features. For example, you can disable the rainbow splash screen that appears when you boot the Raspberry Pi. You can also disable the Raspberry Pi boot logo in your custom distribution. And something that's important, and we're going to discuss in more details, is U-boot. So by default, you build an image that relies just on the proprietary Raspberry Pi firmware for booting. However, you can also use U-boot, and this is the variable introduced by meta-raspberry Pi to switch to U-boot. So now let's have a look at the Raspberry Pi 5 and to discuss a little bit on hardware. Raspberry Pi 4 was announced in 2019, and due to the chip shortage for a couple of years, Raspberry Pi did not release a new single board computer on the market. So Raspberry Pi 5 was really anticipated, and they finally released it at the end of September last year. It was really hard to get a Raspberry Pi back then. There was a shortage of supply initially, but nowadays a Raspberry Pi 5 can be easily purchased, and there are a lot of distributors providing it. It comes with more powerful CPUs, more powerful GPU, It has a dual HDMI display, just like Raspberry Pi 4. It also has the 40-pin GPIO header, which was introduced in 2014 with the Raspberry Pi 1 Model B+. So this is backward compatible with all Raspberry Pi add-on boards that you have used through the years. So Raspberry Pi 5 has some new hardware features. We're going to discuss them from both software and hardware point of view. And when it was released last year, the community started efforts to support it in meta-raspberry Pi. Foreign opened a GitHub pull request at the end of October. I joined the efforts and made some contributions to it. There was also a valuable input by Gaio, and Cam did a lot of reviews. So finally, this GitHub pull request was merged by Andre on 25th of January this year. And you might be wondering, why did you need like 3 months to get this machine merged? What was so specific about it? Well, there were and there are still things that are a work in progress because there are a lot of hardware changes. Actually, initially, the support was for Raspberry Pi 5 without U-boot. By the time when this GitHub pull request was merged, U-boot was not yet ported to a Raspberry Pi 5. Another thing that we had problems with was the config.txt file that I briefly mentioned at the previous slides. And I'll explain this in detail. So yeah, it took us quite a lot of time. Also, this December, as you know, it's a holiday season, so that a little bit slowed the process. However, now Raspberry Pi 5 is a first-class citizen of meta-raspberry Pi. The machine Raspberry Pi 5, there is a single machine Raspberry Pi 5 because Raspberry Pi 5 boots a 64-bit kernel only. And the images that we built for Raspberry Pi are 64-bit only. This machine is available for Yocto releases Scarthgap, Kirkstone, and in the current master branch of meta-raspberry Pi. So you can use Raspberry Pi 5 with all long-term supported releases of the Yocto project that are actively maintained right now, as well as the ongoing development. This is the final Raspberry Pi 5 machine configuration file in meta-raspberry Pi. And initially, as I mentioned, the U-boot support was not available. It was added later on, but now U-boot is also supported. There is a recipe called rp-config. It is used to generate this configuration file, config.txt. It's a text file. And as part of the efforts to port Raspberry Pi, we hit a really awkward problem. So it appears that due to some changes in the proprietary bootloader of Raspberry Pi, to which we don't have access to the source code, there is now limitation of the size of the file, the config.txt file, or the include file, which is 60 kilobytes. And when you have a long file with a lot of commands, this is a problem because the Raspberry Pi doesn't boot. So for the moment, what I did was to apply a very simple fix to use set to get rid of all of the commanded out lines. This way, the config.txt file becomes significantly smaller. However, here is an idea if you're looking for a way to do an upstream contribution that's important for the community. I think there is an opportunity here to completely rewrite the way this rpi-config recipe works and to generate the config.txt file in a different way. At the moment, it takes like a template with a lot of commands and turns on and off some of them. And finally, we do this set single line command to reduce the file size. Here are some links. I have already uploaded the slides so you can check out the details. Now, let's have a look at the new hardware features of Raspberry Pi 5. Finally, there is a power button on the side, and also there are GPIO pins, so you can add an external bigger power button. You can put the Raspberry Pi in a nice looking case and have a button to turn it on and off. There's also a real-time clock, and there is a PCI Express interface. This way you can attach fast peripherals like AI peripherals or SSD drives. In order to do this, you need an add-on board. So the Raspberry Pi Foundation, the Raspberry Pi company released on the market an M.2 Hat Plus for connecting NVMe SSD drives, and also an AI hat with a Halo accelerator. There are a lot of third-party solutions as well, because a lot of companies decided to make add-on boards using the PCI Express. Here in the middle of the slide, you see a couple of screenshots of devices that are done by Pimoroni. This is a company from the UK. Again, they made these extensions to use the PCI interface on Raspberry Pi 5 to attach either one SSD or two SSDs. This is just an example. There are actually a lot of boards on the market capable of doing this. The interesting thing about these boards is that you can put it below the Raspberry Pi 5 and save the 40 pins on the GPU for another add-on board. That's why I like them. One of the things that kind of shocked me the first time when I got my hands on a Raspberry Pi 5 was the Raspberry Pi 3-pin debug connector. So basically now UART is enabled by default. You no longer need to set enable underscore UART equals to 1. This is a variable coming from meta-raspberrypi when you're building an image. And you can just use the UART connector available on the Raspberry Pi. However, there is a catch. It is with it's a very small connector, very specific connector. So you need a proper wires to get access to it. It's not just a UART connector, it's also for a 2-wire serial debug interface. Here are the pins and how they can be used. The easiest way to actually use it and to get a proper cable is to buy a Raspberry Pi debug probe. So this is what I did. Raspberry Pi debug probe is a device, another device provided from the Raspberry Pi as a company, and it comes with their own Raspberry Pi microcontroller. This is the Raspberry Pi RP2040 microcontroller. The same is used for Raspberry Pi Pico. As you probably know, Raspberry Pi as a company decided to enter the microcontroller market as well. And in 2021, they released Raspberry Pi Pico with this microcontroller. It's also used for the debug probe. So the camera and the display interface, there's a MIPI camera and display interfaces. They're bidirectional, which means you can use them for both display and a camera. Raspberry Pi also released an AI camera, second generation of their 7-inch display with better resolution. So they changed a little bit the pinout. So if you have, like me, the first generation of this display, which was released 2015, I think, almost 10 years ago, you need a special cable. This is the number of the cable here in the slide. So this cable is needed to connect the Raspberry Pi 5 to the old DSi display, the first generation DSi display. Beware that as of the moment, using meta-raspberry Pi, you won't get proper hardware GPU acceleration using a monitor attached to the DSi. If you are building Core Image Western, Western is the reference compositor of Wayland display protocol. A fix is coming soon. There is work in progress and a GitHub pull request is open. So what happens right now if you build an image? This is kind of a thing that you have to keep in mind, that the hardware acceleration works fine if you attach monitor to the micro HDMI connector on the Raspberry Pi 5. It loads the VC4 Dream shared object, and the graphics run pretty well. However, if you attach a DSi display, you don't have a hardware acceleration. You are going with software acceleration. Here, one trick to improve the performance is to alter the Western ini configuration file and switch to Pixman, but you still be with software acceleration. You just get better results. This is not enough. You can never compare the software acceleration, of course, to the GPU hardware acceleration. So what's the fix? Well, there is a work in progress that was recently opened by Bassem in meta-raspberry-pi. It's a GitHub pull request that hasn't been merged yet. Because of this, I say that it's a work in progress. It updates the Mesa to version 24.3 that was recently released, I think like 10 days ago. And the other update that is done is to update Wayland protocols to version 1.38. I've tested this GitHub pull request, and I have to say Bassam has done a great job because with it, we have hardware GPU acceleration on the display serial interface and the official Raspberry Pi display. I've tested it with generation 1. I still don't have the generation 2 display. So keep in mind on this, it's in GitHub. If you need to use the DSI display, this is something that's going to be very important for you. Another problem that we had was with U-boot. So as I mentioned initially, when Raspberry Pi was announced, the work for supporting it in meta-raspberry Pi started. It took us several months to get everything merged, but we had to turn off the U-boot from meta-raspberry Pi for Raspberry Pi 5 just for this machine, simply because U-boot at that time didn't support it. However, things changed thanks to contributions from Ivan Ivanov, who's actually also from Bulgaria. I live in Bulgaria, but I've never met him in person. He had done a great job. He took some patches that were contributed by Dmitry Malkin to the U-boot mailing list, and he improved them and got Raspberry Pi 5 properly working with U-boot. These patches made it to U-boot 24.04, in other words, in April this year. And here comes the problem. Yocto project, as you know, has a very strict release schedule. Every 6 months, there is a new release, and we have long-term support releases. So at the beginning of this year, we were still with Kirkstone, which was originally released in April 2022. So it came with a very old bootloader, 2022.01. Obviously, Raspberry Pi 5 is not supported in it because the hardware was not available when this version of U-boot was released. Then we have Scarthgap, which came with U-boot version 24.1. This is a U-boot version from January. This version also didn't support Raspberry Pi 5 because, as I mentioned, the patches from Ivan and Dmitry were merged in the version of U-boot in 2024 April. The good news is that Styhead, Yocto release 5.1, sorry about my pronunciation, I'm never good with the code names of Yocto. It was originally released this September. It came with U-boot 2024.07, which supports Raspberry Pi. Everything is fine if you use it. However, what happens if you want to use the long-term support release of Yocto Scarthgap with Raspberry Pi 5? Well, here comes my colleague Tim Orling. He rescues the situation because Tim contributed Yocto Open Embedded layer called meta-LTS mixins. Actually, this is an existing and well-known layer, but he contributed a branch for Scarthgap that adds U-boot. Basically, it provides U-boot 2024.04 that has been backported to Scarthgap. And thanks to this layer, you can use meta-raspberry Pi with a U-boot loader that supports Raspberry Pi 5. To enable this, you have to use the standard approach using this variable that I've have already mentioned. This is meta-raspberry Pi specific versions. So this is only for Scarthgap. As you have seen from the previous slide, if you're using a new version, you don't need it because you already have have a version of U-boot that supports Raspberry Pi. However, if you are using a long-term support, Scarthgap, which is the latest and greatest long-term support release for the Yocto project, if you're using Raspberry Pi 5 and you need U-boot, you have to use this integration layer that provides backported U-boot. Thanks to Tim for doing this. It's really convenient, especially if you're working on Raspberry Pi 5 software over-the-air updates. There are several solutions for software over-the-air updates that support Raspberry Pi 5. Balena.io is a Docker container-based software update and management system for Internet of Things devices. They were ahead of game with Raspberry Pi 5. Foreign who opened the GitHub pull request in meta-raspberrypi for Raspberry Pi 5 actually works for Balena. The other solutions, Mender, Rock, and SW Update rely on AB updates. I had a separate talk comparing these three solutions a few months ago in Vienna at the Yocto Summit. So you can have a look at the slides from this talk for details. So these three solutions, Mender, Rock, and SW Update, rely on U-boot. So in order to use them with Raspberry Pi 5, you need a U-boot, and it's recommended to use a long-term release Scarthgap as of the moment, which means that you need the layer created by Tim. So we're at the end of this presentation, so let's wrap it up with some conclusions. As you have seen, meta-raspberry Pi is a great board support package layer maintained by Andre and the community. There are a lot of contributors. I'm a contributor as well. It supports Raspberry Pi 5. Nowadays, it supports it really good. You have U-boot, and soon you have the hardware acceleration for the DSi display. Config.txt file is something very specific for all Raspberry Pi models and versions. With Raspberry Pi 5, it's limited in terms of size, which makes some problems. And for the moment, we have a simple solution. But if anyone is interested in making something more sophisticated, contributions are welcome for AirPi config. There is a work in progress for the newer Mesa and Wayland, which will provide GPU hardware acceleration for both the micro HDMI and the DSi. I've explained about the U-boot. So in a nutshell, you need U-boot 2024.04 or newer to run it with Raspberry Pi 5. You have software over-the-air updates working pretty nice with Raspberry Pi 5, and these solutions such as Mender, Rock, and SW Update rely on U-boot to do the switching between the A and B partition. So what's next? Well, Raspberry Pi as a company is very, very active in 2024. Just a few days ago, they've announced Raspberry Pi Compute Module 5. So obviously, they are looking into more professional and industrial embedded Linux customers. Thank you very much for your attention. I hope this presentation was useful or at least entertaining. And I highly recommend you to have a look at meta-raspberry Pi and to get involved with upstream contributions. If you have time, thank you very much.